Welcome to another edition of ProSoft Technology video training. In this video, we will walk users through the first-time setup and configuration of the MVI69E AFC module. ProSoft Technology's in-chassis flow computer solution for CompactLogix allows you to monitor gas and liquid meters for flow rates, accumulator values, and other calculation results. This solution eliminates the need for multiple RTUs and standalone flow computers for a multi-well pad application. In this scenario, let's say we have a well pad with multiple meters we need to take readings from, calculate flow rates and pressure, and then transfer the results to our PLC for use in the application ladder program. So here is all the hardware we'll be working with along with their respective IP addresses. This will entail downloading all files and installing eAFC Manager software, the first-time setup and configuration of the MVI69E AFC module using eAFC Manager, incorporating the AFC module into an RSLogix or Studio 5000 project file, and finally configuring the sample add-on instructions for the meter run and the tags required for a user project. So let's begin. I have my new MVI69E AFC module installed in my CompactLogix rack. The first thing I need to do is download and install eAFC Manager software from the ProSoft Technology website. This is a free application that is used to configure and monitor the MVI69E AFC module. And while we're on the product page for the MVI69E, we'll also go ahead and grab the add-on instruction file so that we can set up the module in our CompactLogix program. Once we have all the files downloaded, go ahead and install EFC Manager to your PC just by following the prompts. The add-on instruction file that we downloaded is a zipped folder that contains the main add-on instruction as well as 4 additional AOIs, one for each of the main meter types. And this would include a linear gas, linear liquid, differential liquid, and differential gas. We'll go through what each of these are and when you would want to use them. Once eAFC Manager is installed, go through the Start menu and browse under ProSoft Technology and choose the eAFC Manager. Once it opens, we'll go to File and create a new project. Select New, MVI69E AFC, 12 meters, and the version number will be V4.04 or later. It's important to match the product version to the firmware version the module is running. So if you're not sure which firmware version you're running, you can find it on the web GUI by pointing your web browser at the IP address assigned to the web server. The default web server IP for the module is 192.168.0.250. So once you have the new project open, the first thing to do is configure the overall settings for the site. These settings will apply to the entire project. So from the Project tab, select Site Configuration. This will open the Site Configuration dialog box. Right at the top, we have the site name, and you can edit this if you need to. The primary and virtual Modbus slave IDs are used for access of process, configuration, and historical data for the site and all meters. The defaults should be fine, but you can change it to any address from 1 through 247 if you need to. It is, however, generally recommended to leave the primary Modbus slave ID at the default of 244 so that only the IP address is needed to connect to the eAFC. The virtual slave is an advanced option. It's used for more efficient data pooling, and setting its address to any value greater than 0 will enable it. End of day minutes specifies when daily archives will be created. By default, 0 minutes means midnight. You can go from 0 to 1439. End of hour minute specifies when hourly archives will be created from 0 through 59. There's also barometric or atmospheric pressure, site options, and pass-through settings here. And you can enter all that information as needed. The next thing to do is set our communication parameters. The network, serial 1 and 2 buttons allow you to configure the settings for each of those ports. We'll click the network button, which opens the configuration window for the Modbus TCP port. And this is where you can enter the IP address that you want to assign the AFC module in your application. For the initial download, we'll need to connect via its default IP address of 192.168.0.251. So we'll leave it at the default for now. The mask bits is a way of specifying the subnet mask, and 24 is the equivalent to the typical 255.255.255.0 network mask. Port 502 is the standard Modbus TCP port. We have different module settings and some whitelist options as well should you wish to restrict access to specific IP addresses. At the top, you can see there are 4 server tabs, and these allow you to set different configurations for up to 4 servers. If you do have multiple configurations, you just select the tab and check Enable. The Advanced tab contains more advanced web options. Note that the web interface that you see here is a different address than the network interface. This is used for accessing the module's web interface for firmware updates and viewing module information. We'll cover more of the web GUI once we have the configuration up and running. As for Serial 1 and Serial 2 back on the site config window, when you click on those, you get a window with the serial settings for the 2 serial ports. Port 1 can only be a Modbus slave, so that the eAFC Manager software can always connect over this port. The Modbus Master option, which allows the eAFC module to pull data from other Modbus serial devices, is only available on Serial Port 2. When you're ready, you can hit Done on the site configuration window, and this will close the window and temporarily save the settings. You'll have to save your project before closing eAFC Manager though, otherwise all your changes will be discarded. Once all of our site information is configured, we can move on to configuring the meters that you'll be gathering data from. For this section, we'll cover 5 distinct steps: meter identification, meter device, product group, units, and primary input, common parameters, application-specific parameters, and configuring the port settings. You can select the meter being configured here on the top left. We'll start with meter 1. The meter tag is a name that you can assign to the meter if you choose, but for this video, we'll go ahead and just leave it at the default. Additionally, there is an identification button where you have the option of specifying details about the meter, such as the manufacturer and serial number. Here in the meter type, product group, and unit section, we can describe the meter being used. So under device, you can select the general type of meter, either differential or linear. Then under physical device, you can select a more specific type that will determine the calculation standard that's used. For the broad range of other meters available today, your selections will depend on the output generated by the meter. So refer to your meter specs and Section 4 of the MVI69E AFC Module Setup and Configuration Guide for more information. I have 2 meters, so I'll set up my differential gas meter under meter 1 using US units and my linear liquid meter under meter 2 using the standard SI units. Next, you'll choose the product group. Now, for most applications, either gas, crude oils, or NGLs and LPGs will be the typical choices. But for special applications, there are other options. And finally, the primary input, pulse count or pulse frequency for linear meters, and differential pressure or flow rate for differential meters. The parameters you choose in this section will determine what other parameters eAFC Manager will display. You'll notice that as I make changes here, the displayed parameters change. Only the parameters that pertain to your meter type and instrumentation and its primary output will be displayed. The common parameters apply to all applications. They do not change according to your selections up here and should be configured. They include reference temperature and reference pressure, as well as the units to be used for accumulators and flow rates. Now, the application-specific parameters are those that are contingent on your selections above. For instance, you could have the frequency flow threshold and pulse input rollover be displayed for a linear pulse count meter, or you could see differential pressure threshold and V-cone wedge discharge coefficient for a differential diff pressure meter. Whew, that's kind of a mouthful. Now, if you set gas as the product group, you'll have the gas parameters to configure here, or the liquid parameters if you chose liquid. So if you choose a linear meter, such as a turbine, you'll also have the K-factor characteristics here, where you can select the units used for the K-factor definition. I'll click the Process Input button, where I'll set the valid input ranges. Here I can enable high and low alarm thresholds. So if I get input data that is outside the configured range, the MVI 69E AFC will trigger an alarm for that process input. If you are setting up a gas meter run, you will need to configure the Molar analysis settings. First, click the Analysis Config button in the meter configuration box, and under the Component Selection tab, you can select the various components to be analyzed. We suggest you select everything because if you ever need to feed additional components into your program, it will make it quick and easy for you to do so. You would also set the normalization total error tolerance value. This is in parts per million, so 10,000 is equal to approximately 1% of the total composition. I'll enter that. When you're done, click OK. Next, click on the Analysis button. Under Stream 1, here you will set the concentration percentage for each of the components that you'll be analyzing. The percentage of each component is expressed as a number between 0 and 1. So, for example, a molar fraction of 0.85 would mean a concentration of 85%. The fractions you enter should roughly add up to 100%, and it depends on your normalization setting in the Analysis Config window. When you're done, click Done. Now for your information, setting the molar component ratio here in eAFC Manager, as we've just done, is something you would do if your ratios are coming from a lab analysis report or something along those lines. If your component ratios are coming from the readings of a gas chromatograph, then you can actually set the ratios to update dynamically in the controller tags. Now that our meter runs are all configured, we are ready to connect to the MVI69E AFC module and download our configuration. You can connect using either the Ethernet or serial ports. I'll connect over Ethernet, so just plug into the Ethernet port on the module and connect the cable to your PC or a switch on your network. Under the Communications tab, select Local Port Settings. I'll choose TCP/IP under the Transport options. As stated earlier, for the very first download, the module still has all its default settings, including a default IP address of 192.168.0.251. Click the Copy to Local button, and the IP address field should populate. In order to connect, your PC will have to be on that subnet with the AFC. So when you're ready, click Connect, and if all goes well, you should see that the COM link is open. You can click OK to close the window. Now click Project and select Download Project. If you've made any changes since your last save, you'll be asked if you want to save the project. Next, the Login window will come up. Enter a 3 under Operator Number. This is the default to log in as the administrator. Click OK, and the download will proceed. The configuration will now be sent to the module. Click OK when the transfer is finished. We can now set the permanent IP address. Note that a full project download is only required the first time a project is downloaded to the module. Afterwards, each configuration section has its own read and write buttons, and specific configuration sections can be written to the module without having to download the entire project. So if I go to the Network Advanced tab and set the orphaned connection timeout to 1 minute, I can apply this and then click right to change just this part of the configuration. Then we'll return to server 1 and change the IP to what we'll use in our application. And again, click Apply and Write. This will change the module's IP, and note that our connection will be lost after this. We'll have to switch to the new IP and its associated subnet in order to reconnect. Before moving on to RSLogix 5000, we will create and export some custom UDTs for our meters. Once we have them in our RSLogix 5000 program, it will make it much easier to view and work with the calculation results and other data. We'll start by clicking the backplane return button in the meter configuration window. This opens up a new window where we can edit the registers that we want to include in our UDTs and then export them. We have a tab for process inputs, which by default includes the most common calculation result data for the meter. You can just use these, or if you want something specific, you can go through the dictionary on the right here that lists all the available registers. In order to bring in something new, you will have to remove something from the list. So I'll give up C prime. So highlight it, click Remove Item, and this will open up 2 words. Then with the first available slot selected, I'll highlight Flow Rate Mass and click Insert Item. We'll switch over to the Component Analysis tab, where you can select any additional data from the AFC that you'd like to have available in your PLC program. There's nothing selected here by default, so if there's anything you want to monitor, just find it in the list, highlight an open spot on the left, and click Insert Item. Once you've made all your changes, you'll likely notice that the export buttons are grayed out. We'll need to save the project before we can export. So click OK on the backplane return window. It'll close and we'll go up to File and Save. Now we'll go back to the backplane return window. You can see that the button is now available. So we'll click Export UDT, and when we do this, a pop-up window will appear with the UDT name, the name of the actual file, and the folder location where the file will be placed. Now the first time you export a UDT here, it will create a new folder in the same location as your eAFC Manager project file. You can click Yes. And you do this again in the Component Analysis tab. This UDT file will be added to the same folder that we just created for the Process Input UDT. Now, if we click the Archive Configuration button, we can also create UDT files for daily or hourly archive reports. I'll export one for my daily archive. Now, as you can see, there is a default list of archived registers, and if you do need to make any changes, you can use the same method of removing and inserting items. Again, you'll have to click OK and save the project before you can export. I'm just going to go with the default archive configuration, so there are no changes to save. I'll click on Export UDT, and the file will be saved to the same subfolder as the other UDTs. Well, that should do it for the eAFC Manager. Next, we'll open up RSLogix 5000, or if you're using Studio 5000, that's fine as well. You can create a new project or bring the AFC into an existing project. I have a new project up and running here, so we'll start by bringing in the MVI69E AFC. In the Controller Organizer menu, expand I/O Configuration, select the 1769 backplane, right-click and choose New Module. We'll select a generic 1769 module and click Create. On the New Module window, we'll give the module a name, MVI69E-AFC. COM format should be set to data int. Select the slot where the AFC module resides in your rack. For me, it's in slot 2. And finally, the connection parameters should match what I have here. If you need to make an adjustment to the RPI setting for your application, you should also do that as well. And we don't recommend using an RPI setting below 5 ms. So when you're finished, click OK and close. Now we have the MVI69E AFC module under the I/O configuration folder. Next, we'll bring in the add-on instructions. So drill down through the tasks folder and open up main routine. Right-click on any empty rung and choose Import Rung. We'll browse to the location of the rung files that we downloaded and extracted. We have a differential meter type for both gas and liquid, as well as a linear meter type for both products. Be sure you choose the proper add-on instruction for the type of meter that you're using. In my example, I have 2 meters. I'll be getting readings of differential gas pressure from a differential or orifice meter. So I'll use the differential gas AOI. In the import configuration window that opens, if you click on the tags section, you can see the controller tags that will be imported with the AOI. Ensure that the local X tag references are pointed at the correct slot number and that the meter number referenced in the tag name matches the meter number assigned in the eAFC Manager configuration. So once you're done, just click OK. For the second meter, I'll need to get data from a turbine meter measuring crude oil. So I will also bring in the linear liquid AOI. These meter-specific ladder files can all be placed on the same rung if that works better for your ladder file. And now you can see here that each AOI imports with a default meter number of 1 to 4. Now you'll want to ensure that the meter number actually matches what you have set up in eAFC Manager. For meter 1, we brought in the differential gas AOI, which defaults to meter 1, so we didn't have to change anything. But here, the linear liquid AOI defaults to meter 4, so we'll have to make an edit. So as you're bringing in the import, there are 2 meter name references here. I'll change meter 4 to meter 2. Again, ensure that you have the right slot number under the local X. And there's actually a third reference that we can only see in the ladder rung. So when it's finished, you can go to the ladder and change this last reference from meter 4 to meter 2. Once you have imported an AOI for each meter in your project, you'll need to import the main MVI69E AFC AOI. It's important to import this AOI only after you've brought in all of your meter AOIs. And it also needs to be placed on its own rung. So just select the next open rung down, click Import Rung, and go through the process once more. Again, we'll change the local X reference here in the import configuration window to ensure that it's pointed at the correct slot number for the AFC. Once this is done, we can see all the user-defined data types as well as the controller tags that will be used by the sample program. Next, we'll bring in the UDTs that we exported earlier. Begin by going down the tree view to Data Types and right-click on User-Defined and select Import Data Type. Browse to and select the various UDT files that we exported from eAFC Manager. On the import screen, there's nothing we need to do, but I'll just point out that if you ever want to bring in a new UDT to replace one that you brought in previously, under this drop-down where it says Create, you'll have the option to select Overwrite. Select that and you'll replace your previous UDT with the new one. Click OK. As they come in, you'll find the UDTs toward the bottom of the data types list. Now we'll need to create a new tag of the UDT type and then use a copy instruction to map the raw data to this new tag. So we'll do that first. Open the controller tags, click on the Edit Tags tab, and then we'll click here to add a new tag. I'm going to call it Meter 1 Calculation Results. For data type, we want to reference the UDT that we just brought in. Now, in some versions of Logix, you can actually just drag and drop data types from the controller organizer window. Otherwise, just browse down the list of data types to our EAFC rectype backplane return meter1 process variable UDT. And make sure that you're looking under the user-defined folder, not the predefined folder, like I was the first time I tried to do this, and click OK. Next, we'll return to the main routine and add a copy instruction to the first open rung. On the instruction, the source will be the raw data starting at AFC meter1 differential gas, backplane return, process input, and we'll drill all the way down to the data 0 tag. And the destination will be the custom tag array that we just created for it. You can just select the root folder, and the length will be 1. The process input calculation results will now populate in this new tag, complete with proper names and data types. They are now ready to be used in the rest of the PLC program. And you'll simply repeat this process for each UDT that you want to bring in. So for component analysis, we'll create a new tag with the data type pointing to the EAFC rectype backplane return meter1 AZ, which is our component analysis UDT. And again, we'll create a copy instruction. The source will be AFC meter1 differential gas, backplane return, component analysis, data raw 0. And the destination will be our new additional data tag. For the archive data, the data type for the custom tag will be the EAFC rectype archive meter1 daily archive UDT. And for the copy instruction, the source should be AFC meter1 differential gas archive fetch raw 0. The destination, as you probably expect, is our archive record custom array. And this is how you bring in the custom backplane return data. And you just do this same process for each meter in your project that you have UDTs for. Keep in mind that the backplane return component analysis data must be triggered in order to view it. You do this in the controller tags under meter1, backplane return, component analysis, trigger. You just enter a 1 here, and the component analysis data for this meter will populate in the tags here and be copied into the array that we set up for it. You'll do this for each meter as well. And once you have all that squared away, it's a good time to save your project. You can now go to WhoActive and download the project to your Rockwell processor and set the program to run mode. So let's take a quick look at the 69E AFC's web page. Typically, this is used to update firmware and view general module information. It's accessible through any web browser just by typing in the module's web address. A new feature allows you to monitor what's going on inside the module. You would just click the monitor link on the left, and you will have information on each of the 12 available meters. If you then click on a specific meter, you can see general overview information for that meter. You can also hover the mouse cursor over a meter, and a general range of subheadings will come up. You can then click any of these links to see even more specific information about the meter configuration and operation. This is a convenient way to quickly check on the module and meter status. Just a tip, once your meter is enabled, you'll not be able to change the meter type or the product group. To make changes to this section, you'll have to open up the control options and deselect Meter Enable. Write this change to the AFC module to deactivate it, and then you will be able to edit the meter configuration again, if you need to. And that does it for this configuration. And we've just scratched the surface of the options, capabilities, and other functionalities available with the MVI69E AFC. So if you have any questions or would like more information about the AFC or how to use it, visit our website at www.prosoft-technology.com or feel free to give us a call. Our technical support staff can get any information you might need about the AFC. And if you found this video helpful, please give it a like. And if you're interested in more training and educational videos about industrial communication gear and technology, subscribe to our channel. Until next time, happy training.